My name is Michael. Today I will be talking about how to use NGINX as an Ingress controller on Kubernetes. Just briefly about me, I work at F5, and my job is to integrate NGINX with popular platform technologies, and Kubernetes is one of them. So Kubernetes enables us to deploy and manage containerized applications across a cluster of machines. So this is our imaginary cluster, and we can run different kind of applications there, circles, rectangles, triangles. But at the same time, we still have our users, and we want to deliver those users want to access our applications through the internet. So we need to deliver those applications to our users. And to do that, we need to have a proxy. A proxy and a bunch of other technologies, such as global load balancing, API gateway, WAF, CDN. So we need a proxy, and Kubernetes doesn't come with a built-in proxy. So one of the greatest things about Kubernetes is that around Kubernetes there is a huge ecosystem of tools and solutions. And for our proxy, we would like to have this proxy to be able to integrate with those solutions as well. So our answer is to for this, for the proxy for Kubernetes is NGINX, and in this talk, I will show you how to use NGINX as an Ingress controller to deliver applications to the users. So again, we have a cluster here. In this cluster, we have our application, two circle pods running, and we have our users. So if we would like to use NGINX as a proxy, the very simple approach is just to deploy it outside of the cluster on a virtual machine or a server, and then just configure it to load balance among those circle pods. And this approach is used, but there are more effective solutions to this problem. And the approach also presents a few problems as well. So the first one is service discovery. So imagine, so Kubernetes makes it effective to scale your applications or even auto-scale them, depending on the load. So if we want to scale our application, and this would be the command that you would run, so we're scaling our circle application from 2 pods to 3 pods. So we need to update our proxy. So how do we do that? Well, NGINX Plus is capable of discovering backend pods through DNS, so this problem can be solved. So we don't need to change the configuration when we do the scaling. But there is another type of change that can happen to your applications and in the cluster is when you want to deploy a new application. Like for example, to our circle application, let's add a triangle application. So we do that. We use again kube control tool to interact with our cluster. So now how do we update NGINX? So NGINX configuration is a text base. So you have textual configuration file, and then you update the configuration and then reload NGINX to use the updated files. So, and with our NGINX here, we can do that. We can just SSH into this server and change the configuration files, or do that through some automation. But at the same time, this approach is different with the approach we use to deploy the application. So we use the Kubernetes control plane, and what we see is like a mismatch. So we also want to use a it will be very convenient to use Kubernetes control plane to also manage the configuration of the proxy. So there is an answer. Kubernetes comes with a load balancing configuration called Ingress Resource. So, well, on Kubernetes in general, your interaction with a cluster involves creating different kind of resources to deploy application, resources to deploy secrets, such as CLI certificates. And one of the resources is Ingress Resource. And with Ingress Resource, you can define a load balancing configuration. So for our application here, we call this application shapes. We want to expose the application through the hostname, shapes.example.com. And so for requests that starts with /circles, we want to route those requests to the circles pod. So I have some animation here. So for the request that starts with /circle, we want to route them to the circle pods, and the request with the URI that starts with /triangles, we want to route such requests to the triangle pod. So Ingress Resource, again, it's a built-in resource into Kubernetes, and it allows us to define this configuration. At the same time, so there is an answer to this to the question of if we can also manage load balancing configuration through the Kubernetes control plane. So we will use Ingress Resources for that. However, NGINX natively doesn't understand Ingress configuration. It has its own configuration language. So what do we do? So in Kubernetes, there's also a concept of the Ingress controller. So the Ingress controller is a special software. It runs inside the Kubernetes cluster. It talks to the Kubernetes API to get the state of all the Ingress resources currently created in the cluster, and then this software converts those Ingress resources into the configuration of a particular proxy or load balancer, and then it applies that configuration to the proxy. That load balancer can be something that runs inside the cluster, something that's external to the cluster, such as a cloud load balancer or a F5 big IP device. In case of NGINX, NGINX Ingress Controller runs inside the cluster, and it runs in the same pod, same container as NGINX as well. And this allows us to run NGINX in Kubernetes as well. So it's not we don't run it outside of the cluster. We run it. It's inside the cluster. So there are two NGINX Ingress controllers out there. There's one here on the right, which is a part of the Kubernetes project, and also there is one that we have developed at NGINX. So in this talk, I will mention, I will be talking about the Ingress controller that we have developed. So with NGINX Ingress controller, so this is how the this is the deployment diagram. We have our circles and triangles, pods. We have users, and we have the NGINX Ingress controller running inside the cluster. There's one little step here missing. Is since Ingress controller is running inside of the cluster as well, we need to expose it to the outside of the cluster. So we need to provide it a stable endpoint, stable static IP address, or just IP address, and also have a load balancer so that we can, for high availability. And you would typically run the multiple replicas of the NGINX Ingress controller as well. So this missing step is placing layer 3 or layer 4 load balancer outside of the cluster. And in cloud environments, this could be a cloud load balancer, and in your own data centers, it is possible to use the big IP or even NGINX as a load balancer here. So now I also mentioned the features available through the Ingress Resource. So Ingress Resource is actually very limited. It only covers the basic use cases. This is another example, and it shows every feature that is available. So first, TLS termination, so that you can secure your web applications with TLS. The second feature is host-based routing, so we can route requests based on the host header. And the third feature is path-based routing, so you can route requests based on the URI. And that's all. But what are the other features which are important to application delivery? Well, additional kind of routing, for example, based on the headers or cookies or request method. You can also apply policies such as rate limiting, or you can also authenticate clients. So all those features are missing from the Ingress Resource. But at the same time, like NGINX, a solution like an NGINX is an advanced load balancer, proxy. So it has all these features. So we need a way to expose those features to our users in Kubernetes through our Ingress controller. The first approach for that is to use annotations. Annotations is a general purpose extension mechanism on Kubernetes. You can add annotations to any resource, including Ingress. And annotations is just basically key value strings, and that's all. And when you add a specific keys with, to the Ingress, specific annotations to the Ingress resource, our NGINX Ingress controller can see those, and it can drive the configuration from those annotations. Like for example, here we have annotation to define a load balancing method that will be used to load balance our web application. So and our Ingress controller will configure NGINX to use this load balancing method. But in real world requirements, you typically use a number of additional annotations as well to configure not only like load balancing method, but
Speak louder.
Timeouts and for example, here we use annotations to configure SSL to the backend services, different timeouts, and also to configure authentication using JSON web tokens. So at some point it becomes very awkward to use them, and you cannot fully, annotations essentially became another configuration language. And it's because those things, annotations are just key value strings, they're very hard to use, hard to validate. And also they're not portable as well. So Ingress Resource is a API that is Kubernetes API resource, but annotations are vendor specific. So different Ingress controllers will typically have different annotations.
Does NGINX provide like a list of annotations to their users?
Yeah. So we have a big number of annotations for different use cases. Authentication, for example, authentication, or configuring timeouts on active and passive health checks.
And are these on GitHub or available?
Yeah. I will show the link at the end of the presentation.
Perfect, thank you.
So so this approach works successfully, but it's awkward to use and it's limited. So both annotations, but also the most important part, the most limiting part is the Ingress Resource itself. Kubernetes has evolved. So Ingress Resource was added like 3.5 years ago or 4 years ago. But a few years ago, there's a new extension mechanism available to Kubernetes called custom resources. So with custom resources, anybody can add a new resource type to the Kubernetes cluster on the fly. And what this allows us to do is essentially create our own Ingress resource, which can provide the resource that we control, the specification of this resource we control, that we can control. And this allows us to provide a better version of configuration where we address the feature limitations of Ingress Resource. Please welcome your VirtualServer Resource. This is our custom resource, and in this case, this is an example of in this example we configure a load balancing for a simple web application and doing TLS termination. And I just compare it side by side with the Ingress resource, which would be used to configure NGINX with a similar configuration. So custom resource, they look and feel like native Kubernetes resource, but as I said, they can be added to the clusters on the fly. And this is the extension mechanism to Kubernetes itself. So with our VirtualServer resource that we added, the idea is that we bring all these features that are missing in the standard Ingress resource. And all the missing features like better routing that I mentioned, or policies like authentication or rate limiting, so that people can use NGINX Ingress Controller more effectively on Kubernetes, and that it can solve, the Ingress Controller can successfully address all those different requirements. And there is no need to use any annotations that I showed you with the awkward syntax. So one of the limitations that we're trying to address is provide support for better routing. I'll give you an example. So what if you want to route requests to split the request between two versions of the same application? 90% would go to the one version and 10% to another version. This is the use case called canary releasing. You deploy a new version of application and then expose it to only a subset of the users. And then you can see, this version is called canary version, and then you can see how this version works. And once you're confident that this version, the new version, works okay, you can make this complete switch. And this use case is addressable with our VirtualServer resource, with our new configuration. So you can configure splits across two upstream servers, and upstream servers correspond to the services, to our different services here. So we have this is how you represent these requirements with our VirtualServer route resource. Another use case is a routing request based on headers or cookies. For example, here we want to route requests to the version 2 of the application if the cookie version is set to version 2. And again, in our VirtualServer route resource, it supports this use case. So you can define conditions on which you want to route requests. And here we define the condition to inspect the cookie and then match the value of the cookie to the version 2 v2 value. And if the match is successful, the request will be routed to the version 2 of the application. Demo. So now I will show you everything in action. This is a live demo, but I will use a helper tool called Demo Magic. So it will eliminate the need for me to type. So you can find this tool on GitHub. So I will not be typing, but in any case, this is a live demo. It's not pre-recorded. So the first thing is using kubectl command. I can show you my cluster. And you can see that I have, that's a, good thing I noticed. Okay, can you guys see that? I'm gonna make this font bigger. Okay, so I run the kubectl get nodes command, and you can see that I have a cluster with 3 nodes. It's a cluster I created in Google Container Kubernetes engine. And I'll show you now that I already deployed the Ingress controller. It runs in a pod in a cluster, just one pod. And I also expose my Ingress controller to the outside of the cluster, to external clients, using a Google Cloud Load Balancer. so with this IP address. Now, I also already deployed my application pods. So this is an example from the slides. So we have one circle pod and two triangle pods and the corresponding services for them. So now what I want to do is to configure, to use our VirtualServer resource to expose our application, to expose our circles and triangles pod to our clients. So for that, what I will do, I would create this VirtualServer resource. The configuration here is simple. We just define a host, shape.example.com, through which our application will be available. We define two upstreams that corresponds to circles and triangles services. So upstreams represent a load balancing pool in our configuration. And then we define two routes. So the first route is for a request that starts with circles. We will route them to circles upstream, and the requests that start with /triangles will be routed to the triangles upstream. So let's create this resource. Let's create this resource in Kubernetes, and now we can try to access our application. I will switch to the browser, and I will type shapes.example.com/circles. And this is our circles application. It's very simple, just a web page that returns the IP address of the pod where this application is running. You might notice that I used shapes.example.com domain. So in my etc host file on this system, I map this domain name to the external IP address of the load balancer that I showed you previously. And similarly, we have, this is /circles, and I can do /triangles. This is our triangles application. So it looks similar, but with a different header here. So this is basic use case of the Ingress controller. But let me show you some more interesting stuff. Let's try to deploy the new version of a triangles application, version 2. So I created another deployment. I just created another deployment in Kubernetes cluster. Now let's see if the pods were created as well. So we have triangles version 2 pods running. So now what I will do is I update my load balancing configuration here. So I have another version of the virtual server. So I added another upstream to map to the triangles version 2 service. And here in the route for triangles, I added a split. So now 50% of the request will be routed to the first version of triangles, and the remaining 50 to the second version of triangles that I just deployed. So let's update our VirtualServer resource in the cluster. And let's try to access our triangles path again. So this is a response from the version 2 of the application, as you can see. And let's refresh a few more times. So as you can see, for some requests, and some error is returned. So this means our new version of the application doesn't behave well. Something's wrong. So what we can do, we can go back and we can update the VirtualServer resource, and we can update it to the version that we used the first time without the second version of the triangles app. So let's do that. And let's try to access the triangles path again. And again, so now we're not seeing any responses from the version 2 of the triangles. And this is an example of using canary releasing as approach that I was talking that I talked about previously. In this case, our canary version didn't work well, so we switched back to to the initial first version. I have a few more slides left, so let's. Maybe there's any questions about the demo. I can answer immediately. Okay. So let's switch back. Let me start. Go back to my slides again. Great. So what I showed you, I gave you introduction on how NGINX can be used as an Ingress controller on Kubernetes, and how it can be integrated in Kubernetes. So you configure it using Kubernetes resources rather than just actually writing NGINX configuration. And you configure and deploy it through the Kubernetes control plane. So I mentioned that Kubernetes has a large ecosystem of tools, and it also runs in the cloud, in your own data centers. So NGINX Ingress Controller integrates with some of the tools. I could as well. It's a subject of a different talk, but I just want to mention that. And we also, since NGINX can run anywhere, so it's also portable across one cloud provider to another cloud provider, or to your own bare metal Kubernetes clusters. And for our new configuration, so our Ingress controller supports the standard Kubernetes Ingress Resource with some limited but basic features. You can also use annotations to extend the standard Ingress Resource and use more of NGINX features, such as authentication or rate limiting. And then we introduced the new configuration based on custom resources feature. And this new configuration is when it really enables you to use NGINX at its full potential. It supports advanced routing. But at the same time, we released the new configuration this year in our latest stable release, and it's new. So we still have a lot of features actually coming to it. So we're currently enhancing our support for load balancing, so you can configure things like timeouts or health checks, circuit breaker. We will be adding support for policies, so you can do authentication, rate limiting, rewriting the request to the responses, and support for TCP UDP load balancing. We will be adding additional resources to support TCP or UDP load balancing. So this concludes my presentation, and here you can see the links to our open source project. It's available on GitHub. Okay, thank you.
Just had a quick question on the cross namespace configuration.
Oh.
Is that only for within a single Kubernetes cluster, or are you guys actually doing that across multiple resources that are being balanced? So if you're running multiple clusters across multiple site locations for
Okay, good question. I actually missed it. I put it in a slide. So the cross namespace configuration, what it means. So Kubernetes cluster can be used by multiple teams. And in this case, it can be used, each team can have access to their own namespace where they can deploy and run their application. But at the same time, load balancing configuration, so you can, for example, if we go back to our triangles and shapes and circles app. So triangle spot can actually run in one namespace managed by triangles team, and the circle spots can run in a different namespace, but managed by the different team. But to our users, we want to expose those circles and triangles using a single host name. And this means that the Ingress controller, NGINX, will have to route requests to different namespaces based on the request URI. So with standard Ingress Resource, it's not supported. So with our VirtualServer Resource, it is supported. We actually have another resource called VirtualServer route that enables this support. So you can split the configuration for the host name and for the path in two different resources, and you can distribute the configuration for the particular path across namespaces. But this is more complicated subject. But at the same time we support this. And you also ask about the you also mentioned that load balancing across clusters. So with Ingress Resource so with NGINX Ingress Controller, there's no support for routing across the clusters. At the same time, it is so if you want that, you will have to use additional load balancer in front to implement this support. But there's a related feature. You can use Ingress Controller. You can configure it to route requests to the destinations outside of the cluster as well. So the feature called external name service. So with this, you can run some of your applications inside the cluster, and you can use the Ingress Controller to route requests to those parts of your application inside the cluster. And the other parts can still run on virtual machines or servers, or in auto-scaling groups on AWS. And the Ingress Controller can also route requests to those destinations, those external destinations as well. I hope that answers the question.
Yeah, that's what I was asking.
So a question for you. You'd mentioned that in your next version of stable code, you were adding features for like health checking and things like that. Is that not available in this code, or you're just expanding the list of things that you can check?
Yeah. So with our first version of the custom resources, we just covered some basic features and some extended, some advanced features like support for splits and routing based on headers. But we haven't yet implemented support for a mechanism to configure health checks, or active connection, active and passive health checks, and a bunch of other things as well. So we will be releasing the next version this fall, next month, and in the next version we will include those configuration options.
Okay.
So, you talked about using the NGINX as an Ingress controller as opposed to, I guess, the standard Kubernetes Ingress controller, right? Mainly what I got from it was that you can support maybe some capabilities and features that don't exist in the standard Kubernetes Ingress controller. Mm-hmm. At some point, I would think like there's going to be more feature parity as Kubernetes becomes more mature, and some of those benefits that you guys might be able to support right now might actually, they might be able to catch up. But would there be some other compelling reasons for somebody to deploy an NGINX as an alternative for the Ingress controller? Would there be some other benefits there? I mean, I see enhanced load balancing, mm-hmm. but what else? Is there maybe performance, or just by virtue of bringing it into an NGINX platform, we can do mm-hmm. other cool and compelling mm-hmm. types of things, like there's security implications, or mm-hmm. what other types of benefits would we have as a result of just trying to figure that out?
Okay, that's a good question. So I'll try to answer. So Kubernetes, the Ingress Resource, so the Kubernetes actually doesn't come with the Ingress controller. So that's up to the user to choose a vendor, a project.
Okay.
And there are a bunch of options, but there is no default Ingress controller. Although particular Kubernetes versions, for example, Google Cloud or AWS, may ship, the Ingress controller for their particular load balancer. So right now, the generally available Ingress resource, this is what I showed you. At the same time, right now there is a work going in Kubernetes project to create a new version of the resource, version 2, that addresses some of the limitations, similarly to what we do here. At the same time, so Ingress Resource is a general, it's a API to cover, it's a common denominator API. So it tries to cover the basic use cases, the basic set of use cases that all different vendors can support the same way. But a lot of features that we want to offer cannot be added to the to that API to the Ingress resource, simply because other load balancers don't support those features. Cloud load balancers, for example, they only have a limited set of features are not that it doesn't limit it in a way that there's a limit to what they offer. So if we have the Ingress resource that is limited, there must be a good mechanism to extend this Ingress resource. So right now, for the standard, right now we use annotations for that, and other vendors use annotation approach, where they add their own vendor-specific configuration. So the next version of the Ingress resource, the version 2, the goal is to address to extend the API to the basic API with more features like support for better routing, but also there is a work to offer better extension mechanism so that vendor-specific features can be easily added to the Ingress resource, and they don't look as ugly as annotations. And but another part of your questions was why to use NGINX here, because the Ingress resources, if the version that Kubernetes will provide will catch up, and every Ingress controller will implement those features, why NGINX? And thank you for answering it for me as well, because you mentioned that there is a larger story here, and so that Ingress controller is only part of the set of tools of technologies that are needed to successfully deliver the applications. So I didn't mention global load balancing, WAF, caching layer, or then inside the cluster the service mesh. And our approach that Rob presented is to provide a solution that can manage everything for successful application delivery.